Well, Anthony, this is your life. It's time to address a few glaring issues that you seem to fall into regularly. I want to try to address only science. Of course, there's enough there to fill a book. First, you treat science as if it were a legal court case, and a debate as if you were cross-examining a witness. Your method of winning is to find a hesitation or spot where the other person is unsure, and then you hammer on that one thing until you back them in the corner and they finally have to cry uncle or admit they don't know. And so you do this with BM hammer or BM furball, sorry. I think that in U.S. courts, the judge would say you're badgering the witness. Along with that, I have to say it's just about unethical that you and other flat earthers like to pick on very green science students that are just out of college and then grill them cold on flat earth issues. I've seen 3 of these debates where you have students that have never even considered flat earth or curvature. Sometimes you're asking them things that are not even part of their field of expertise. And the express purpose is to humiliate science people in front of an audience. The next time you finish one of those interviews, pat yourself on the back and think you were really good at humiliating those guys. Once again, science is not the same as law. If you were a lawyer and were presented with evidence you had not seen before, you would ask the judge for, a continuance or some time that you could consider the new evidence, right? These students have never studied debate. They've never dealt with a person seasoned at flat earth issues or your techniques of winning a debate. While I'm here, let me say that science students in any field are never drilled on the scientific method. You seem to have this obsession with the scientific method. The scientific method is a set of guidelines used to keep an experiment focused and on task. I'll deal with this a little later. You're going to see some examples. Also, if you were a lawyer, you would be most adept at changing the subject. If a topic comes up that you're not prepared to deal with, you carefully turn everyone's attention to a topic better for you. Secondly, lately this Einstein letter has surfaced and you jumped on it to show how Einstein was an artist and not a physicist. So, I don't know if you have a legal method like we have scientific method, but you skipped a lot of steps to get to that line, Einstein's more of an artist than a physicist. I believe this is begging the question. You're assuming the outcome before you even talk about the first part. A scientist, here's you an example, following the scientific method would ask first, is this letter real? There's my question. I do some background research. I would, to see if it's been dealt with before, I would quickly find, sure enough, several places, Snopes and other places, have shown that the letter is fake. They give some reasons. So you could take those reasons, check them with the letter, and see if you believe it's fake or not. A scientist would find those places that say it's fake and would not need to proceed, would just call it off. You might, as a peer review, continue as a scientist. You could take a look at it as an experiment, look at each point made and verify whether it's successful or not. That brings you to making conclusions. You can draw conclusions about its veracity and about the content of the letter. And then it would be acceptable to make further examinations or conclusions. That, sir, is the scientific method. Okay, so the third thing that's been all around YouTube lately is your dissertation for your master's degree. Your degree, I think you said, was legal research. I don't know about the British university system, nor the British legal system. However, in the U.S., I'm very familiar with what the schooling is like for a law student. And the student first has to have a 4-year degree and then applies to attend a law school, a specialized graduate school. If they're accepted, they attend a 1-year kind of an initializing program. If they can't pass that with an A or a B, then they're denied access to the school. If they pass that, they get into law school. After 4 years of law school, they graduate as a Doctorate of Law, LLD. But still, the student cannot practice law until they've passed the bar exams. The bar exams are intense. It's not like taking a final exam for a class. And then the whole process of this is very intense. My relatives that went to law school were not able to work and go to school at the same time. So I wish you luck if you're going to go that way. So as we talk about universities, I do have a master's degree in experimental statistics. I've taught the scientific method in graduate school. The dissertation is a critical part of any master's degree. First thing, I had an advisor that helps me pick a topic and guide me to success. If I had failed the dissertation, I would not have been awarded a degree, period. I would have also had a group of panel of professors that would review my dissertation. So Let me say that your dissertation was for a legal subject, law, and not for science. You wouldn't have taken much science as an undergraduate, maybe, introductory courses, one or two, and for certain, you wouldn't have taken any in graduate school because you're a law student. So I'm sorry, but you're not an expert in any field of science, and you shouldn't question the science of anyone that has gone through 6 to 8 years of college, intense training, has written a dissertation or a thesis for a PhD, and then carefully has been reviewed by a panel of professors, and then this person has years of experience. So going back to your paper, you start off with some legal points, each which are carefully researched, well defined. You address the reference and you talk about different legal things. But it seems to me, it's my opinion, that at the end of the legal part, you felt like you didn't have enough for a dissertation, so you shifted off into science of flat Earth. None of those points had been researched. There were no references. It was just conjecture, things out of your head, and they were in no logical order. There was no logic to when you switch to the science. There was no legalese in that part, and under your definition, no science. No scientific method, no just it would have been all pseudoscience. Again, this is just my opinion. You could have used the scientific method to write your thesis paper. And you would have written a much more professional dissertation. You would have defended your position better. You would have had background research already in place. It just would have been a better thesis all around, a dissertation. Your overall premise is faulty, again, because there's no single consensus for flat Earth. If you speculate that it should be taught alongside the science model, or if it should replace the science model, it should have a single set of ideas that flat earthers could agree on, which they never do. Let me give you an example. If you ask any flat earther what is the shape of the earth, you might get it's a circular disc with an ice wall. I've heard it's an infinite plane in all directions. I've heard that it's a rectangular disc with corners. I've heard that it's a circular disc, but then there are other continents beyond. And so this is the very most basic part of flat Earth, and you can't even get agreement on that. So again, the scientific model has one set of parameters, one set of ideas. and flat earthers have none. There is not one thing that they agree upon. Okay, so my fourth thing, science versus pseudoscience. Pseudoscience is another word that you continually preach about, harp on, seem to be obsessed with. Science is not cut and dried like that. You quote a definition for science that was from Webster's Dictionary or something. It was intended for the general audience and very, very generalized. So let me suggest, this is just a suggestion, that you should switch your terms to theoretical and experimental. So look at trying to divide how a scientist works as between theoretical and experimental. There are fields that fit under one or the other or both of those. There are scientists that are research scientists, laboratory scientists, there are field scientists. So unlike your most recent video, Einstein was not a pseudoscience any more than a research lawyer is a pseudo-lawyer. Einstein was a theoretical physicist. His calling was to push the boundaries of physics, to postulate theories that fit accepted science, but then push beyond that. Hence, the theory of relativity, which has been discussed, talked about by many different physicists since then. Guess what? His theories of gravity did not supersede Newton. Gravity is, they extended Newton's work. Gravity is much more complex than just why do things fall. And yes, I have references for all of that. So do me a favor, drop the pseudoscience versus science, and especially drop religion versus scientism. Scientists do not worship somebody. We don't bow down to Einstein or Newton or Neil deGrasse Tyson. Everything is proof and facts. So since I brought up gravity, let's go there next. My fifth thing. You continue to preach and harp about gravity is not a force. I just saw you posted a recent new video that gravity is not a force, density is a force. So let's just look at that briefly. I'm not going into deep science here. The dimensions of force is kilograms time meter divided by seconds squared, or they kind of combined all that into newtons. If you look that up on Google, that's what you'll find for force. So let's look at forces. There in a force, there is mass, there is distance, there is time squared, or time. Mass, distance, and time is part of a force. As Newton's first law says, force is a mass, kilograms, moved a distance m in s seconds. So Little g is an acceleration and has units of meters per second squared. So Newton's second law says force equals mass times acceleration. So scientists began looking for an acceleration that could cause objects to drop or whatever. So hence we had little g, and little g seems to work under every circumstance. And so force equals mass times acceleration. So the force of gravity is kilograms times meters divided by second squared. These are the exact units of a force, unquestionably. If you look back at Newton's first law, it's the same exact units. So now let's look at density and relative density. They're both defined as mass per unit volume. They have dimensions of kilograms per meter cubed. So the units are wrong. There is no distance, there is no time involved. All that they have is mass and volume. So you can't call density a force. Density is a property of matter. If chemists or geologists or biologists find a new substance, they classify that substance by its properties, and they look at density, they look at mass, or not mass, but they look at transparency or color, hardness, many things like that. And density is one of those, but they don't, but density is not ever considered as a force. So you have this density or relative density, and neither one is a force. And then you have some other term that you seem to have made up out of your head, relative density disequilibrium. I looked that up on Google and Google Scholar. It's not a term that's used anywhere. I can't find it. So apparently it's something you made up and you decided is what we use instead of gravity. So just real quick here, let me add that buoyancy is a force, but it's a specialized force. It only acts in the upward direction by definition. That's what buoyancy is. So if you put a ball in water, it floats because of buoyancy. If you have a balloon full of helium, it goes up because of buoyancy. So the factors that affect buoyancy, just real quick, the density of the fluid, which could be atmosphere, could be water, could be the ocean, the volume of the fluid displaced, and, get this, the local acceleration due to gravity. So gravity helps to define buoyancy. The buoyant force is not affected by the mass of an immersed object or by the density of an immersed object. And yes, I have references for that. So you clearly have the terms weight, mass, density confused, and you really, honestly, you need to go study those things. You can't just look up the math, which you seem to be always saying, don't do the math, but then you use the math, F equals MA, I've seen you use. They're not the same thing. Weight, mass, density, those are not the same thing. Yes, they're related, but they're not. And yes, weight contains little g. Weight has to do with gravity. Mass has to do with the object itself. It's a and then density we've already talked about as a property. Sixth, so I showed you examples of scientific method. I'm not going to cover those steps. You obviously know the 7 steps of the scientific method, and you quickly call people on how they don't know how to use the scientific method, and so they do pseudoscience. It's not science unless you do the scientific method. So let me assure you again that the scientific method is just a guideline. It's a set of steps. Scientists don't have to follow each step, and they don't necessarily follow each step in order. Again, it's just a guideline. However, you, Anthony, quickly call people on how they can't use the scientific method, but you, yourself, never used the scientific method. You did your egg experiment, you looked at this Einstein paper, you wrote your dissertation. Never once did you reference the scientific method. Never once have you ever done any research to show references or whatever. So I'm pretty sure that you have no concept of what the scientific method is. And I'm pretty sure most of your other videos are the same. Let me talk about your egg experiment for a minute. I was pretty shocked by the way you did your egg experiment. You showed a complete lack of understanding of the rigors of science. Every step of your experiment is wrong. You used the wrong equipment, whatever that thing was you stuck in the glass. You didn't use research to find out what that equipment is. You didn't check and notice that floating egg experiment is regularly done by 3rd graders, 8-year-olds. You didn't look up density values for water, salt water, or egg. Your hypotheses were completely invalid and unusable. And I guarantee you, every scientist fainted when you dumped salt in that water and said, look, I made that egg move. Your experiment is a test of buoyancy, not density. So that entire experiment was just an exercise in futility. I could go on and on and on, Anthony, never found a single video of yours that is correct. And I've watched a lot of them. I comment regularly, although they seem to go unanswered a lot. You can debunk me if you like. You can tell me I'm wrong. But if you're going to tell me I'm wrong, you need to point to a place where I said something wrong, and you need to explain why I'm wrong. You cannot just dismiss me by saying I'm wrong and that's it, or cognitive bias, or whatever you want to say. I think I'm worth a little more than just a simple statement. If you simply wave your hand and say pseudoscience, then you're proving my point about you not being able to do the science. And I would suggest, as kind of a closing line here, don't tell someone else that you did not use the scientific method until you can prove that you understand the scientific method, each step, and why it's used. And that's kind of all I had planned to say. I did have one other thing that has been on my mind. I saw a video where you said density is shown to be a force in the scientific method. And I haven't yet had time to watch that, but the scientific method itself doesn't prove anything. Scientific method, again, is a set of steps used to conduct an experiment. It's the experiment that proves or disproves something. And so, just about everything you say proves that you are not an expert in science. And when you dismiss someone like A.B. Science or Dr. Bob or Professor Dave, you're just showing the Dunning-Kruger effect, which you seem to be full of or rife with, I guess. So I'm going to close there, but I want you to at least give some thought to what I've said.